Today I'm going to be discussing with you 6.1 through 6.3. These are continuous distributions, and they include both the normal and the uniform. Just like discrete distributions, continuous distributions sum to 1. Continuous distributions, the probability is defined as the area underneath the curve, or in the case of the uniform distribution, the area inside of the rectangle. The first one we're going to look at is the uniform distribution. The uniform distribution is basically a box that has an area of 1. We can use our standard area formulas, which is length times width, to calculate the area inside the box or the area in part of the box and find the probability of an event occurring. Next, we're going to look at the standard normal curve. The standard normal curve applies to science studies, psychological studies, anything that deals with people and how they are distributed. The normal distribution always has a mean of 0, standard deviation of 1. If the data that you're working with is not normalized, meaning it has a different mean and a different standard deviation, then you will have to use the z-score formula to find your z-score and then use the tables in the back cover of your textbook to find the appropriate area. There's also a flow chart that helps with this. And the flow chart is on page 284. On page 284, you will see a flow chart, and it tells you how to find certain probabilities on whether to use one tail, two tail, whether it's the area in the middle. One important thing about the normal distribution is it sums to 1. Half of the distribution, meaning from 0 to positive infinity, is a half. 0 to negative infinity is a half. So a lot of times with the standard normal curve, you will be having to use the symmetries, either subtracting off 1 or subtracting off a half or manipulating it from there. So it's all about reading the tables and applying your standard normal curve to that. Always think of them as an area. So the area underneath the curve is the probability.